Okay, me first. Yes, I'm Sara, and we're a floating power plant, and I manage the research and development of our floating power plant, which is a combined wind and wave device. And this is Anders.
Yeah. I'm the CEO of the company. Have been so for the last 7 years, representing the 156 shareholders we have in our company. So my daily work is raising equity, doing business development, and then closing the projects, where Sara runs the R&D team. Well, the company is a Danish limited company. We are owned by 156 shareholders, and we develop a combined floating wind and wave device. It consists of a floating semi-submersible structure, which is actually kind of like a floating oil and gas platform, where we have added wave power and a wind turbine. We are actually the only company in the world that has actually deployed a half-scale prototype providing power to the grid for 2 years with a combined wave and wind device.
So there's a lot of synergies of wave and wind on the same platform. And so we are effectively a floating wind platform that uses wave energy both to get more power on the same platform, but also the wave energy devices rotate the entire platform so that it faces the waves, and this leaves a nice still water area aft of the wave energy devices where a boat can land to do O&M with safe boat transfer. So yeah, that's a big part of it, which reduces the LCOE, which is something we strive for.
So the key part of the combination is we get a low cost of energy. That's the driver with the synergies that Sara so well described, but it also gives us a unique market segment to be able to go where there is larger waves and larger wind, where normal wind and floating wind cannot go today. The reason why we are combining wind and wave is bigger market segment, lower cost of energy. Those are the two key parameters of combining the two things. If you look at the benefits, it is more power on the same platform, a more stable platform, better O&M access, meaning you can access your facilities, you can get on board, there's some better power profiles. But combining two technologies comes with a lot of challenges. When you put two things together, you get more risk, you get something that's more capital intensive, and those are something that takes more time. And developing technology is a lot about time and money. So you're actually applying a lot of factors into your business development process that is actually risk. Naturally, the goal is to provide a better technology that's what's in there in the market, but you're actually providing risk in your development path. The reason why this is a good time for combining different business areas, if you look at the key environmental impact of renewables, that is space. It doesn't matter if it's space for a wind farm, if it's space for a solar farm, if it's space for growing biocrops. That is the environmental impact of renewables. But if you look at all the massive goals that are both in Europe but also on a global level to increase the amount of renewable energy, then we need more space. And I'm sorry, I come from Denmark. We don't like looking at wind turbines anymore when they're outside our window. So we need to go into the offshore space. And if you go into the offshore space, there's a lot of benefits about combining different technologies, because people think that the ocean is big. It's not. There's a lot of competition with commercial traffic, with aquaculture, with leisure, with a lot of different elements. So actually making the most optimal use of the offshore space with the lowest environmental impact it's a good way forward. It's not easy, but it's the right way forward.
So fixed foundation wind is financially feasible only up until around 45 to 50 meters water depth. So beyond that, in order to get out of sight of land and to make use of the rest of the space, then you would have to start floating the turbines, which is where we come in. We're floating wind technology.
And we come from Denmark. Denmark is one of the biggest developed country within offshore wind, and the initial parks were made within 1-2 kilometers. Now you see parks being developed within 10 or 20 kilometers out, but in the future you will see massive wind farms in 50 to 100 kilometers offshore, and that is, as Sara say, in the deeper water segments, over 45-meter water depths, and that's where you need floating wind, or as we do, combining floating wind and wave.
We use standard components wherever possible. So I don't know if that's exactly the same question. It's not necessarily other combinations of technology, but we take standard components such as, for example, a semi-submersible structure from the oil and gas industry. We're using that in renewables. So we're taking ideas from other industries and using them in our own.
Our entire company is built on partnerships. We don't develop this alone. We develop with Siemens, we develop with Future Energy, we develop with a lot of companies because we are trying to integrate knowledge from the offshore wind industry, from the oil and gas industry, from general industrial things, because combining wave and wind in the offshore segment sounds really, really easy. It's not. So gaining the experience from all our partners and using standard components is a key part of this.
Well, I could probably answer a little of this because I'm maybe one of them. So my background was mathematics and wave energy. So I came in after after a PhD from England to Denmark to help the research and development side of the company. But we also have to have specialist naval architects, electrical engineers. Combining different technologies at this means there's a lot of specialisms, and it's also a new combination. Nobody else did it before, which means everything is new, and we need people to be very innovative. Yeah.
That is a key part of what we're doing, and getting people from all over the world to travel to Denmark is actually quite difficult, but it's a huge part of what we're doing. And the other part of the balancing is balancing business development with technology development. You cannot just develop technology, or you cannot just develop business. There has to be a sound balance. So finding people that can actually both do technology, but also knows what business means and communicating, it actually makes things a little bit harder. Our end users is big utility companies. We sell technology to Dong, E.ON, Vattenfall, and so forth. And they very, very easily understand our value proposition. The challenge in this combination of multi-use space is you're bringing higher risk, more capital intensive product to market. So the customers or the end users, they know what we're doing and they value it and they completely understand it. But taking that co-investment into technology risk can be hard, can actually be a very hard thing to convince end users to do. They just want to buy the final product. So making them wanting to take that extra step into a risky project is difficult. So they understand what we're doing completely and why this is a good idea, but turning that into a long-term strategic investment is a challenge. That's not just for us, that's for the entire multi-purpose area.
So, yeah, I could say a little. So the Maribe Project is provided us with some experts, for example, with cost modeling. So it's been very nice to have some different people to go through our cost models and our business plan with. You probably can say more on this.
It's business model and our business development is something we spend a lot of money on. We also have a professional board of 7 working on this, but actually in the Maribe context, having different specialists providing input on what we do every day, it's quite nice to have people come by and say, but why are you formulating it this way? Why is this your value proposition? Shouldn't it be just challenging a little bit on what we say every day? And that it's been a nice framework for being challenged.
This is a very expensive industry. So unlike the wind industry, fixed foundation wind this has been developed over so many decades and is now very advanced. We're combining floating wind and wave, and in the future these will be definitely part of the energy mix. But at this early stage, we need support to make it happen.
I think the key things, it has, if you could call it opened, it has by having a session like this today where you have advisory panel, you have a lot of business to business meetings, there's network being developed. So network is I would say a key thing we are taking out of this. A key part of Maribe is actually as what you call it, as we as an industry are saying, here's multi-purpose areas and presenting those multi-purpose projects towards the European Commission, saying here's different projects and technology that you can use to fulfill your both renewable goals, climate goals, but also an effective use of the offshore space.
We definitely enjoyed being here. As Anders said before, it's been good for networking, but also the advisory panel this morning. It was nice to get some feedback from lots of different people from different industries.
Definitely, the diversity of the panel created some interesting discussions where you can see they triggered each other on the way they actually looked at technology like this. So that was quite interesting. I think that a key statement to the public is that multi-purpose use will come, and it'll come fast, as the offshore space is a fantastic place to develop new technology that can bring a lot of both benefit it can bring a lot of benefit to the everyday citizens, both in the form of cheaper energy, more stable energy, non-dependent of energy, that is actually out of sight of where you live every day. So we can use the space on land for more normal things.